So, thank you very much for inviting me to take part in this conference. I'm really sorry that I can't be there. I really wish I could be, but hopefully this video will do to kind of show you what I've been up to, and also to hopefully give you some ideas as to how we might possibly collaborate in the future or do something else with the STRO. So first of all, a bit of a background. I'm an archaeologist currently living in Aarhus in Denmark. I specialise in databases, geographic information systems, and also online delivery of archaeological data sets. And I first became interested in the incredible resource that is the Sound Toll records online by a colleague here in Aarhus, whose father is very interested in the gunpowder trade during the 30 Years' War. So he'd previously been making the trip every day to view the original records in the library in Copenhagen, taking his own notes, actually looking at the original books and everything. And Gru suddenly thought, oh, perhaps he wanted to do some kind of visualization of his results, and maybe we could do something with maps, basically, to show the gunpowder trade spatially. So I did a little bit of digging online, and of course I came across the ready digitized version by you guys. And as everybody knows, it's an absolutely incredible resource, and of course the database itself is very easy to navigate. It's very, very well structured to allow kind of complex querying and also collation of results, and as well obviously as statistical graphs of chosen commodities or passages or what have you. But one thing that was really missing for me when I was looking through this database was the ability to see these results displayed on a map, and also to see how those commodity routes and everything changed over time. So obviously the data is all there in the database. We've got the source ports, the destination ports, we've got the dates of the passages, we've got, you know, the names of the skippers, we've got the amounts of the commodities and everything, and the amounts of the cargo. But what we don't have is the lines that join them up. You know, how did you get from one port to the other? And this is really something that I wanted to look a bit more closely at. To be honest, I was kind of inspired to do this a bit by the likes of James Cheshire at the Centre for Advanced Spatial Analysis at University College London, who took some data from ship's logs that had been digitised for climatology reasons. So the climatologists basically wanted to find out what the weather was like in the Atlantic over from 1750 to 1850. So they digitised a whole bunch of ship logs, and that included the latitude and longitude, which was recorded every day on each ship. So in fact, that then obviously made it possible to log very accurately the routes of the ships, which James Cheshire did, and then created this map here showing the different trade routes for the different nationalities of ship. This then was followed up by Ben Schmidt of Northeastern University in the US, who took that data and then animated it to show the passages over a year. So you can see here his animation of all of the routes over 1 year. Now the data that they use doesn't have any information about the cargoes of the ships, so it's not particularly easy to track the movements of specific commodities. However, the STRO data, of course, does have the commodities. So I set about trying to find out how we could add this spatial dimension to the data, and then use that to visualize the movement of commodities across the world, and obviously across time as well. So the process kind of goes as follows. The first thing to do was to collate a list of every unique route in the database. Then I was going to plot the likely sailing route taken, perhaps using external data if necessary. I link those routes directly to the passages table in the database and then make some pretty maps, showing how these commodities were traded over time. Let's just say at this point that it is currently definitely a work in progress. It turned out to be quite a bit more work than I thought it was going to be. And obviously I've been doing this kind of in my spare time. So anyway, I'll present you with what I've got so far. Initially, I was looking at doing this to just a subset of the data exported, a CSV exported from the online website. But as I got into it, I quickly found out that a lot of the transcription and a lot of the original entries play kind of rather fast and loose with place names and that kind of thing. There's hundreds of different names for certain places. And as an example here, when we're looking for Aarhus, for instance, there are actually 107 different place names and spellings that have been attributed to the port of Aarhus. So when I came across this, I was pretty much ready to give up kind of before I started. However, I got in touch with Jan and Ubo at the STRO, and they very, very helpfully provided the geographic concordance tables which they've made, along with, in fact, the SQL download of the entire database, which was extremely helpful, completely essential, and very, very, very much appreciated. So now, rather than just going by the name itself, or the 107 different spellings of the name, it's possible to go by the unique code which had been assigned to that port. So, for instance, for Aarhus, that's 043AAR. So, after importing the database tables which had been supplied into my own database server, I was then able to run a query against the passages table to find all the unique combinations of source and destination ports. So this is basically all the unique journeys that you can do, all the combinations that you can do. So Amsterdam to Riga, Amsterdam to Gdansk, Gdansk to Amsterdam, Riga to Bordeaux, or what have you. All of these unique combinations. And so it turns out that there was actually 31,733 different unique combinations of source and destination ports. That was at the time that I ran the query. Obviously the database may have been updated subsequently, so that number may change, but it's around 32,000 different unique combinations. And you can see some of these unique passages just starting from Aarhus here. So what have we got? We've got all sorts of things there. Aarhus to Stockholm, Aarhus to Gotland, all of these different journeys. But it is, of course, important at this point to note that each of these 31,733 routes would have been used multiple times. There are nearly, I think, 1.5 million passages actually digitized. So obviously people went from Aarhus to Amsterdam a lot of times during that, as recorded in the passages table. However, these 32,000 are the unique combinations of source port and destination port, meaning that if I could create the spatial data, basically the line which joins these two ports for these 32,000, then I can reuse that spatial data for any of those passages within the 1.5 million passages for use with those unique routes. Okay, hope that makes sense. So far so good. So I have collated the list of every unique route in the database. So the next thing to do was to create the spatial data for the actual routes themselves. And of course, this is where things get a little bit sticky, a little bit difficult. How do I plot these routes between these 32,000 different routes? I originally, when I did a subset of it, started drawing them in a geographic information system by hand, but then quickly realised that there was far too many of them for me to draw by hand. So I decided to try and do it programmatically, of course. And the easiest thing here would be to load this table into a geographic information system and then draw a line between each of the source and destination ports in the unique passages table. This is what it turns out like. So this is a map, as you can see, almost of Europe, showing one line for every one of those 32,000 unique passage combinations. Not really that useful, can't really see anything from there, but it does show you how well connected the world was at that point. So we needed to filter, I needed to filter that data set a little bit, and it does get a bit easier to see. So if we just show the passages taken from Aarhus, so where Aarhus is the source port, where the commodities are going from, it's a much nicer, more easy to see map. And even from there, that's telling us something. You know, most of the traffic from Aarhus goes east. Unsurprisingly, of course, as it's got to go through the Sound, the Öresund, to be registered in the toll records anyway. So that's not that surprising. But with these straight lines, while it shows us how connected Aarhus was to the other ports throughout the Baltic at least, it still does look a bit more like a flight path map rather than a sailing map. And it doesn't really give us this idea of the weight of the traffic which is going through the Sound itself. So I wanted to kind of create some more useful looking sailing routes. And this actually proved to be quite difficult. So the first kind of port of call, pardon pun, was to see what was already out there. What other data sets are there that I could use. So that data set that I showed earlier, which was built from the ship's logs of vessels crossing the Atlantic, could really have worked beautifully to give us some idea of the possible routes taken by the ships in the last 500 years. Unfortunately, though, it doesn't really reflect the passages of traffic through the Sound, the Öresund, and it especially doesn't show the passages to any of the ports through in the Baltic Sea. It really is just a. While there are some of the journeys which go into the Baltic, most of them go across the Atlantic. So that wasn't particularly helpful. There's also modern shipping data that I could perhaps use as a proxy for historic routes. So, for instance, the marinetraffic.com website shows the current location of the entire world's global shipping stock. It's an incredible data. It's absolutely amazing. If you haven't been on it, you should go on it because it's really awesome. You can click on each one of these little boats and see the name of the ship and also where it's going and where it's come from. And this marinetraffic.com also contains a large amount of historical data as well, historical being in the last sort of 20 or 30 years, I think. Excuse me. It also has a voyage planner functionality, which could potentially be very useful, which basically is a little bit like Google Maps or something, and it allows you to input 2 different ports and find the best route between them, and it really does work extremely well. And actually I really thought that I'd hit the jackpot here, so I could put in plotting a route between Aarhus and Bordeaux. Brilliant, easy, look, shows you the route, that's great, no problem, okay, I can do that for 31,000 different routes. However, there was one fatal flaw in this plan, and that is the Kiel Canal, and in fact all of the other canals which have been dug in the last 150 years. So rather than our nice trip to Bordeaux from Aarhus going up around the north of Jutland, of course, most modern shipping happily chugs on through the Kiel Canal, which isn't very, very helpful for us, really. There is the possibility to plot routes on marinetraffic.com that avoid using the canals and instead use kind of alternative routes. However, this doesn't work for every kind of port combination, and most of the ports and harbours listed in the STRO archives are actually no longer in use, especially for commercial shipping traffic, and so they don't even appear as options within the database on marinetraffic.com. But it is possible to use a little bit of web-based scripting to remotely query the marinetraffic.com system. And so I ran the 32,000 unique passage combinations through it anyway, by just pinging this voyage planner 32,000 times. And actually it only really returned about 6,000 of the routes, and a high proportion of those actually went through the Kiel Canal. So unfortunately, it wasn't really going to cut it for what we needed for this project. And of course, this is disregarding all the other concerns of using modern shipping data to represent historic routes. Like, for instance, modern ships have engines, and obviously they're much less susceptible to weather and tides, and they don't necessarily need to hug the coast or anything like that. So, what next? Well, as I couldn't really find any modern or any historic shipping data to help visualize these routes, I had to end up making my own. And of course this task could be a massive research project in its own right, and you could get a list of every type of shipping vessel available during the time periods. You'd have to check its sailing qualities, check how close it can go to the wind, plot the tides, access weather data for the various areas, etc., etc. There's a lot of things you could do to actually very, very accurately model these historic shipping routes. But for me, that wasn't really going to work, purely because I didn't have enough time or the resources to actually do any of that in-depth analyses. So I thought that I would take a slightly easier approach, something that I knew how to do as well, which is always useful, and that is to use a classic GIS technique called least cost path analysis. So least cost path analysis is usually used for plotting land-based journeys. So essentially you create a friction map or a cost surface, which is usually an elevation map or something, which shows the various obstacles in a landscape, such as hills or rivers. You then assign costs to those obstacles, and then an algorithm is used to find the path from point A to point B that incurs the least total cost. So you can see on this slide here that point A, it goes from 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, rather than going across those 2s and those 3s and those 4s. The algorithm has managed to find the cheapest way through that map. So of course, creating a least cost path analysis for a seaborne journey is incredibly easy. You assign the land a very, 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 very high cost, so that the algorithm will always avoid the land, and then you set the sea with a very, very, very low cost, meaning that the algorithm will basically always try and stick to the sea. So this is what I did. So this is the those destinations from Aarhus that I showed earlier with the straight lines, but instead this is them displayed with the results of my least cost path analysis. I had to do quite a few experiments with here, and I actually found that it was nicer to introduce a little bit of noise into the sea's cost surface, so that the lines kind of wiggle a little bit and look a little bit more natural, because otherwise they just looked very, very straight, and they kind of followed the coastline very closely, and they didn't look quite right. And bearing in mind, of course, that this is a very simple least cost path analysis, I haven't put in any other things about tides or wind or anything like that. So it really is just go from this point to this point and kind of make the line look a little bit more realistic. And you can see some errors on here already, particularly for the kind of inland ports, because the algorithm just draws a straight line across to the port's coordinates. And some of these ports, of course, would normally be reached by a river, but the resolution of the world map data I was using wasn't really good enough to represent those river areas accurately. So once I had the method worked out, I ran the same algorithm for all of the 32,000 unique combinations of ports. It took a really long time, days. It nearly broke my computer, but actually I think it turned out, in the end, I think the result turned out quite nicely. So this is all of the journeys within, all of the unique journeys within the database. As you can see, these routes aren't entirely realistic, and they do look a little bit wobbly, especially across the Atlantic due to the noise that I introduced. But if you compare them with those 6,000 modern shipping routes that I managed to retrieve from marinetraffic.com, so these ones in red are actual shipping routes taken by modern ships. I think it actually stacks up quite nicely and looks pretty good. So I've plotted the basic routes, and the next thing to do was to start linking those to the passages table, and then to start actually kind of interrogating this data a little bit. So I inserted the route ID, the unique route ID, into the main passages table, which then allows me to link all the other data to the spatial visualization. So here is a relatively simple visualization. And this is showing the routes out of Aarhus, but graduated, the colours changes by the popularity of the route. So the redder the colour, the more passages have been taken along that route. As how many times within the database that particular passage is used. So you can see here that the route from Aarhus to Copenhagen, that's the most frequented route, with over 400 passages recorded in the STRO. Followed by Aarhus to Riga, and then Aarhus to Gdansk. So this next slide shows all of the routes colour-coded by their frequency. So the top 4 most frequent routes in the whole of the database are shown here. So the most used route in the whole of the database is Amsterdam to the Baltic Sea. Okay, useful. But then Gdansk to Amsterdam, and then Riga to Amsterdam, and then the 4th most popular one is St. Petersburg to London. So that's already telling us, before we do anything, about where these, which of the routes are most frequently used, and kind of giving us an idea of over this whole period of the STRO, giving us an idea of these major trade routes. So I've linked those routes directly to the passages table in the database. So now we're finally ready to start including some commodities and to begin using the dates of the journeys to start examining that data and how those routes change over time. We can of course now visualize spatially any attributes or combination of attributes that we want. So we can do all sorts of different things like, what are the most popular routes to take 3 different commodities along, or anything like that. But for the purposes of this presentation, and I realise that I've been talking for a while, I'm just going to quickly show two different commodities. So I'm going to show gunpowder, crute, and cocoa. Now I hasten to add here that these have been kind of pulled out just as examples. There's a lot more refinement that I could do with these examples, but hopefully they'll give you an idea of the potential of this method, and then hopefully people will come to me and say, hey, I'm really interested in this particular question, can you help me show it spatially? So this first one is cacao. So this is a map showing all of the passages in the database that carry some kind of cargo of cacao. That might be cocoa beans, or that might be refined cocoa itself. It's a bit difficult to tell actually from the database. So as you can see, most of and this is all the passages over all time. So most of the cacao trade through the Ursund was basically from and to Europe, right? That's not that unsurprising. Not that surprising. And there are a few transatlantic routes, mainly from the Caribbean and also from Brazil, presumably bringing the raw beans over directly. But we can kind of start to break this down a little bit and see whether or not this pattern changes over time and how it all affects and how external events might affect the trade routes. So we can plot the same map, all passages that include cacao, but then we can animate that to show the passages per year. So you can see here on the bottom right the time changing. So it takes a little while for cacao to kick off. It's not really until the late 1700s, but then there's a super steady trade from Bordeaux through the Sound, and of course this trade is really interrupted during the Napoleonic War, which we just saw then, presumably, well, obviously because of the domination of the seaways by the British stopping the French traders. And during the Napoleonic War there's a kind of brief emergence. This will go round again, so you can kind of keep watching it. During the Napoleonic War there's this brief emergence of Liverpool as a player in the cacao trade, but then following the defeat of Napoleon in 1815, this trade quickly resumes again from France to the rest of Europe via the Baltic. There's some trade from London and the other British ports towards the middle of the 1800s, and then there's an increase in trade from Portugal as well, presumably due to its interests in West Africa. But I think that this really demonstrates quite interestingly how we can use this geographic data to really visualize this trade. I mean, you can really see how important Bordeaux is here for bringing cacao round into the Baltic. I mean, presumably that's originally coming from the French colonies in the Caribbean and in West Africa, and that direct transatlantic trade of cacao doesn't really kick off until the late 1850s. So just by seeing this, you've already started bringing up a lot of questions, and well, at least in my head, it brings up a lot of questions as to why this trade might be changing over time. And then here's another quick example, which is the gunpowder trade. So this slide shows all of the routes that are used to move gunpowder, at least recorded in the STRO. Gunpowder trade begins a little earlier than the cacao trade. There's a small burst of trade during the late 1600s, but then again, following that, a trading pattern is very quickly established. This time mainly between Gdansk and Amsterdam, so coming from Gdansk to Amsterdam. And then also there's a really interesting strong link between Gdansk and Leith in Scotland, and that stays for a little while as well as the time kind of goes on. But I mean, you can really see here this purple line from Gdansk out to Amsterdam, and then the Scottish trade starts happening, and then also there's some trade out to Dublin, and then round eventually into the Mediterranean as well. So I could kind of go on all day really with examples of where geographic visualization like this is useful. For instance, you could plot the various journeys of a specific skipper, or you could do all of the journeys undertaken in a specific year, all of the journeys that carried cargo over a specific weight or what have you. I mean, I haven't even got into, with these visualizations, the size of the cargo or anything. I've just done frequency of passages, but obviously, you know, there may be some routes where they're moving big chunks of a specific commodity, and it would be very interesting to see how that changes over time and how that looks geographically as well. So I just kind of wanted to finish now. I just want to let everyone know where I am with this project and what some of the future angles may be. Currently, all of this is just held on my own server. I've slightly adjusted the main database to include a few links to this spatial data, but otherwise it hasn't changed very much. I did have an aim of perhaps creating a website, or maybe extending the current website, that would allow any of the queries that you undertake, you know, to be presented geographically. In my head, this would be quite dynamic, so you'd be able to click a line and find out exactly what that journey was, when it was taken, you know, what was carried, who the skipper was. But of course, as I've been kind of doing this in my spare time, this project is unfortunately moving at a glacial rate rather than anything quicker than that. So to kind of conclude, I would be so happy to collaborate with this project, because I think it's such an interesting data set, and I really want to help people ask questions of it. So if anyone's interested in kind of moving further with this type of spatial visualization, you know, if anyone's got any research questions that they think might be it might be a useful technique to have a look at, I would love to talk to you about it. And I'm so sorry not to be there to be able to discuss this in person, but all of my contact details are here. Drop me an email. I'd be very happy to, you know, have a Skype conversation or hang out or whatever, share some screens and start putting some data together, because I think there's so many interesting and cool things that could be done with this project spatially, and I kind of look forward to seeing what everyone thinks and whether they're interested, and whether there may be some way we could all work together on it. So I think that's it. I hope this has been of interest, and hopefully I'll get to work with some of you in the future. Please get in touch if you have any questions. I'll be very happy to answer them. Thank you very much.